for giving this opportunity. Thanks for giving this opportunity to the AEE team Western India chapter. Thank you, ma'am, and thanks for this knowledge sharing session, especially this energy conservation and management. Though it is at the bottom of the energy grid, we need to revisit again and again to see where all the energy conservation possibilities, proposals, scope for savings, everything is available at the input, at the intermediate stage, at the delivery stage. This is what I'm going to focus on this chapter now. I'm trying to see the energy losses in the existing system. We can say each and every utility, you can take it as a
Excuse me, sir. Your slides are not moving. Please try again.
Okay.
Take it in slideshow mode.
1 second. It's moving for me as such. Is it? I have gone to second slide. Is it there now?
No, we are on the first slide only.
Okay, I'll do it.
Yeah. Now we are on the second slide.
Oh, I think it's taking time, I think.
Yeah. Some net issues. Yeah.
Okay. We are trying to visualize the energy losses in your existing system, subsystem, and intermediate power transmission components in the utility system. Normally, we are trying to visualize the utility as not a single unit, but it is a system by itself. Let us say if it is a compressor or a blower or a pump or anything, the input, the central processing stage, and the output system. So if you see all the inputs, Bureau of Energy Efficiency has told only one point: monitor the energy inputs of each and every machine above 10 HP running for 2 shifts a day. But now the power tariff has gone up, so we are trying to focus on above 3 HP. If this is monitored with both the kWh meter and the run-hour meter, especially in a batch processing industry, this will definitely help us as it. The first step towards the energy conservation area, whatever it may be, whatever said it may be, energy conservation, efficiency, and then the renewables, everything is there. The first step is towards trim the input parameters to suit to the process, because all the OEMs, they have given their the energy inputs to the process or to the machine based on the safety of the equipment. But let us try to optimize for the given process how the inputs can be trimmed or optimized. Then we have to see for the optimizing the self-consumption of the intermediate stages in the power transmission. I will just go through each and every step in the coming slides and try to, wherever it is there, it is revisiting to the nameplate efficiency. What is the nameplate efficiency and how to restore it to the nameplate efficiency? We are trying to reduce the energy consumption and improve restoring the productivity of the each and every machine production as well as the utility machines. So these are all the zero and low cost measures that is available that can be planned now. And then if you see all the energy efficiency utilities, what all we have been purchased by the industry, they are performing poorly due to in some areas it is due to wrong installation practices. How this can be corrected upon? Let us go by the condition monitoring approach right from the installation stage. So on the energy conservation proposals, wherever it is possible, the wetted parts of the system or the process or the machine, if it is to be replaced or it is to be retrofitted, that also gives an energy savings possibility. Then the auxiliary systems of the main utility systems, they are all designed for 100% of the system, the full load output of the system. But if the industry is in lean mode production, if the auxiliary systems has to be monitored so as to suit optimized to the main what is the input and what is the output, that also the auxiliary system has to be stabilized as it. Then comes the replacement to the latest energy efficiency machines, which increases the productivity as well it reduces the energy consumption. Now I have changed to next slide. This energy to process, coming to the transmission and distribution.
Excuse me, sir. Let's wait for the slide to change. Slide is not yet changed.
Yeah, okay. I'll just keep myself brushing up the inputs before the slide. The You got it now?
No, not yet.
Okay. The national T&D loss, it has come from 35% to 15%. This is what we are trying to apply in the industry also. The end-to-end, the energy loss in terms of end-to-end the pressure drops, end-to-end the temperature drops, especially on the compressed air header. What is the pressure at the incoming? What is the pressure at the delivery point at the point of the machine? Likewise, for the boiler or the steam distribution system, what is it on the steam at the boiler end, before the moisture separator, after the moisture separator, then at the tail end point, especially to the high-end machines. These are all the areas where we can see the TNT losses can be brought down. Instead of 15% or 20%, it can be brought down to 5 to 10%. Around 5% is more ideal now. The slide got changed, ma?
Oh, not yet. I think.
Okay.
And it is not into presentation mode also.
Okay. I think I will go to the
Yeah.
I will go to the normal this one clear. That will be easy as it. I have
Yeah, now it is changing.
oh,
It is now on 4th slide.
yeah, okay. So Bureau of Energy Efficiency guides the consumers to have the energy meter to target the input fuel bills, either electricity or thermal fuel. But some of the energy efficient equipments which have been bought earlier, some few years or a decade back, wrong installation practice and time-based maintenance. These are all the areas we can just look into it, and how to improve from time-based maintenance to condition monitored maintenance. That is the area where we are trying to look upon. Let us try to revisit the routinely to the OEM's condition monitored practices. Get in touch with your OEM, and what are all the condition monitored practices that can be applied to their equipments in your industry, that we can think of it as such. All the production machines, focus on the wetted parts to restore it back by maintenance overall or by replacement, especially the wetted parts, how to improve upon the productivity for the same energy consumption. Then on the utilities, end-to-end energy losses in the following utilities. Let us say the compressor means what is it on the generation, what is it on the distribution, what is it on the usage. And the leakage is a big area. It's a white elephant. In some of the industry, it is more than 30%. In some of the industries, less than 10%. Where this can be reduced by monitoring it and curbing the usage and leakage. That is, usage is optimizing, and leakage reduction is more important now in many of the industries. Fans and blowers also, say for compressor, at least the pressure is there, and if it is leaking, it is definitely known. Normally, it is said 1/3 of the compressed air leak on a given pipeline, it is normally audible to the human ears. That is where we presume it is around 1/3 of the leakage that is happening in the compressed air line or in the header. But the same thing, if we apply to the fans and blowers, generation, distribution, and usage, the static Pascal is not, unless it is monitored and measured only. It is not, cannot be felt by thumb, or it cannot be felt actually in practice. So it needs to be monitored. Then on the pumps, generation, distribution, optimization on the pressure side, for the given flow rate of the pump, what is the pressure gradient that is kept in the suction, what is the pressure gradient it is kept in the discharge, and what is to be there at the delivery point of the pump's delivery point. For the boilers, the steam distribution end to end, the dry steam is more important. See, many of the industries have considered not only for the package boilers, for the high-end boilers also, moisture separator is becoming mandatory not only on the boiler outlet header, but also on the PRDS, but also on the flow metering side, wherever the dryness fraction needs to be maintained less than 5%. See, 95% it needs to be dry. That is the area that we have to look into. On the productivity side, if we maintain what is the hertz that is available from the EB side, and what is the RPM loss in your machines, if it is monitored as a benchmark, a lot of machines, they have their own energy losses due to slippage in motors or slippage in belts or slippage in the machines as it. This also needs to be monitored by condition monitoring. So coming to the equipments process, the aging has been happening in our process, in our equipments, and with the best operated norms or the norms that is suggested by the vendors or the process consultants, experts, there the output production reduces over years. It is called accelerated aging. Due to excess energy, if it is given to the process, automatically the accelerated aging happens, and definitely the output production reduces and the exhaust increases. This is where we have to concentrate. See, some of our machines, any of the production machines or in the utility like compressors or blowers or pumps, wherever it may be, if we have given an excess input and this is delivered the output, normally what is rated and if it is given excess, that makes the pump to have more and pump or the compressor to have more of wear and tear. And this results in the accelerated aging and the derating of the efficiency that is happening in the system as such. Industry has been talking about the energy efficiency for many years, right from 2001, starting with the Energy Act and the Electricity Act and all. But if we can do the talk by condition monitoring of all the systems and subsystems, especially on the utilities and the auxiliaries, I'm trying to club both the auxiliary of the system of the any industry as well as the utility. If they are monitored, if they are matching to the production rate per day or per week or per month basis, this is where the maintenance team can have a proactive role with the management as well as the production to achieve a better specific energy consumption and reduced, that is the operating profit margins can be increased, can be enhanced by this approach as such. See, many of the motors right from 2018 it has been told to change to IET, IE2 motors, but this IE3 motor, IE4 and IE5, many of the industries have already changed. The large group industries have started changing that, even the EC motors. You find so much of appreciable savings are there. So let us try to analyze what is the loss in the existing our system, our motors, and then plan for the replacement of the motors. About the below 10 HP motors, the appreciable savings is there, minimum 10%. Sometimes it goes to more than 15 to 20% also, especially on the 10 HP motors, where many times it is rebound and many times it is not in the rated loading percentage, say around 60 to 80% is the normal loading that is suggested practically. If it is happening or not, that can be seen as it. Another aspect is the pumps, existing pumps. What all the pumps we have bought, it's not 5-star rated. A decade back, we have purchased the pumps. It's not 5-star rated. And the pumps efficiency is around 30 to 40% only. And the latest pumps, the energy efficiency pumps are around 80%. The efficiency is there. So there is a scope for minimum 20 to 30%. The energy efficient pump can definitely take the replacement stage once the existing conditions can be monitored and then further it can be improved upon. For the compressors, the initially reciprocating compressors to the screw compressors to this now two-stage screw compressors, 300 watts per CFM. It was almost 0.3 kilowatt per CFM. Now it is around 0.15 to 0.13 kilowatt per CFM. It is able to deliver the compressors, the latest gen compressors. But let us try to analyze our compressors, what are they giving? It is not an instant measurement, it is a trend measurement. You see, compressor is basically it's a dynamic process variable. It is keep on dynamically changing. So it needs to be monitored for the delivery pressure, delivery temperature and delivery flow. The compressor's delivery flow for the given rated pressure and the temperature, that matters more for us. Then the fans and blowers, the existing blowers, centrifugal backward curved blowers, what all we have in the AHU of the buildings or in the industries or in the air washer units or in the waste collection blowers, it is around 30 to 40% only existing blowers. How this can be improved upon? See, I am trying to say, let us not replace each and everything right away, but let us condition monitor it to see how this can be improved upon. From 30% to say 40% or 50%, it is improvable. It can be definitely be done. How this can be done, let us see it as such. And VFD for a variable torque load, especially for blowers and fans and for some of the centrifugal compressors and pumps, it is becoming mandatory. So instead of waiting for the OEM or for the management to decide, you take the call and you go for a VFD for the existing system, because this will optimize the torque and the speed for the given motor to give to the equipment to optimize the production for the day or for the week or for the month. This is more important. It is very user friendly and each and every industry have gone for the VFD, especially on the variable torque loads. I am trying to see some of the utilities where trying to share the case studies of the utilities where by condition monitoring how this can be improved upon. I am trying first to take the compressor as a subject now. The compressor air has a variable input, like the inputs RH and temperature. See, from the daytime and nighttime, the difference in moisture in the ambient air at various humidity levels. Say at 50%, it is around 27 meter cube per minute means At 80%, it is around 45. It's almost double. So the input variable is more, and the compressor has to deliver the output. And the compressor OEMs always start the FID at 20 degrees Celsius. What is the air density at 20 degrees and what is the air density at 45 degrees? What the delivery point? That itself is a big difference. At 45, it is around 1.09, means at 25, it is 1.22. So the difference is there. So we have to maintain we have to see the delivery temperature also and compensate, give the temperature and pressure compensation for the flow rate delivered at the compressor end as such. Bureau of Energy Efficiency has given an excellent inputs to all the energy professionals, and this is where we have all studied this right from the day one for our energy manager exams, and this is what we have been explaining, and this is what we presumed also. But some of the repercussions or some of the pertinent questions which I am trying to raise now here is, leave alone the 2% savings because of the increased, the choked filter, the power consumption increase. That is what it is taught to us. But what we have observed, especially in the industries, when you are doing the energy audits and monitoring the compressor delivery flow for a choked filter and a free filter, the difference is almost 13%. This is the area each and every OE industry user have to wake up and see what can be done for this asset. See, the B curve says that, but what are all the other deviations that is happening due to choked filter? If you see the compressor FID, free air delivery at the suction of the compressor, that is what it is defined by the OEMs. But always it is a sad delivery only. It's not a fad. It's a sad delivery. The starved air is the air is starved. The air is getting choked at the filter. And you can see what is it at filter at 2700 pascals, it delivers only 6 ton CFM, whereas at 100 pascal, it is delivering 7 ton CFM, a new filter. This is an area we have to monitor the filters, and you can have the air intake delta P, you can have a magnetic gauge or it's a digital gauge, everything is available. What all that is available there in the console, it is talking in terms of bar, but Pascal means it is 1 lakh Pascal is equal to 1 bar. So you have to monitor the air intake filter in terms of Pascal only. It is a case study done by our Synthen Technologies Bangalore, but you can see the 110 kilowatt compressor, screw compressor, it is supposed to deliver 712 CFM. It is the rated CFM, but at 2700 pascals, the choked filter, it could deliver only 6 ton CFM. The graphs that has been taken for an hour, for a day, for a shift, and for a day, and for months also, it is studied. As and when the filter gets choked, automatically the flow rate drops. This is where we have to confirm. I will just show the previous this one. I will just come to you. At 100 pascal, it is 712 CFM. At 2700 pascal, it's a choked filter. After 2 months, it is around 617 CFM. This means to say, we have purchased the compressor to deliver around 0.17 kilowatt per CFM, 0.16 or 1.17. It's the best compressor, branded compressor, but due to the inlet choke filter, it has dropped to 0.20. This is a appreciable loss, especially on the compressed air flow rate. When it is supposed to deliver the 100% flow, this is not able to deliver because the input is getting choked. So that is why I said, let us monitor the end-to-end energy loss in the system, not only on the plant, end-to-end of the utility, end-to-end for even each and every, at the compressor at the input, compressor at the compressor element, compressor at the post air cooler, compressor at the compressed air pressure at the refrigeration dryer, and what is it given to the process. Now, each and every air intake filter for a screw compressor definitely needs to be monitored in terms of Pascal only, and it can be given a IoT products are very much available. You can have both remote alarm and local alarm. See to it that you daily clean that, or you clean it once in a shift, or you clean it once in a week, depending on the usage. Again, the end-to-end energy monitoring comes. For the boiler, we monitor the flue gas monitoring and try to arrive at the indirect efficiency of the boiler. Similarly, let us look into the indirect efficiency for the compressor also, like monitoring. See, we are not trying to calculate the efficiency of the compressor, but what are all that is wasted? The heat of compression for a given compressor is almost 60 to 70% that is going as exhaust at the exhausted hood of the compressor. If the exhaust hood is made narrow or become a chute, automatically the compressor will kink and it will get derated and it will fail also prematurely. It is normally supposed to run for 1 lakh hours, but if the expanded duct is not given at the delivery of the exhaust of the duct area of the compressor at the top, then it is a big problem for the compressed air system as such. And one more point is, all the compressed air users, we are all having the compressed air sensor, pressure control sensor, 4 to 20 milliamps, 0 to 10 bar pressure sensor. We are transducer, I'm telling. We are trying to have it within the compressor hood itself, and that is facing an artificial hike in and high and low, load cut in, cut out. Instead of that, it can be just relocated to the receiver. This will smoothen the pulsations. You can measure the streamlined laminar flow of compressed air, and thereby you can monitor the cut-in, cut-out also can be altered to suit to optimize to the products or the production or to the system as it. See, for example, the old trend is, let us say I'm having a 1000 CFM compressor. I'm having a 160 kilowatt machine. I'm having a 1000 CFM delivery, for which we had a dryer of around 1000 CFM previously, almost I'm telling some 5 years back. But now the trend is changed. A 1000 CFM compressor needs a minimum of 1500 to 2000 CFM dryer so that we can have a pressure drop of less than 0.2 bar across the dryer in the fully loaded condition. When this is applied to the refrigeration dryer, the same thing can be applied to the air intake filter also. That is, one is zero cost monitoring. Daily we are monitoring, and we will have an active spare filter as a pre-filter as a replacement, and we can routinely clean and keep the filter as ready and maintain the Pascal drop across the air intake filter less than 500 Pascals or 1000 Pascals instead of 2000 or 3000 Pascals. There itself, we can definitely have a flow increase from the given compressor, and it's a low cost monitoring and low cost proposal and low cost measure immediately implementable on the day one once you go back to your industry. The high cost is, you can discuss with your OEM. If we are able to double the air compressors, air intake filter, definitely it can withstand for a longer time, and the Pascal drop across the filter will be less, and definitely the flow will be rated to the maximum delivered flow. It will be almost to the 100%, even after say 3 months by condition monitoring. So both the aspects are there. You can take it as a low, this one zero cost, low cost proposal, low cost measure, or you can go for an addition of one more filter, air intake filter, to see that 13% is a huge loss for the compressor, the day-to-day loss. The user has not noticed that, the OEM has also not impressed upon the user. You have to check in the compressor's air intake filter, where you can have 10 to 15% of loss. This is an area to be looked into it right now as such. So this compressed air exhaust hood, what is there and what is the Pascal and what is the temperature? This also is a symptom of inefficiency of the post air cooler for the given compressor. Normally, if the compressor is doing good, is healthy, the compressor house temperature will be around ambient temperature only. If the house temperature shifts to more than 5 degrees or 7 degrees, it shows the compressor is getting extremely heated inside. Localized heat is more. That needs to be reduced. So you have to look into the air intake filter. See, compressor is like a submersible pump working in air. It needs air to be sucked in. It needs air surrounding. The ambient air has to surround the compressor to keep the compressor cool, as at least warm, do not hot, and give you a deliverable healthy kilowatt per CFM as such. Normally, to provide a temperature, static pressure at the delivery above 160 kilowatt machine, you can say 1000 CFM machines, these monitorings can be definitely help you to know the post air cooler of the given compressor. Accordingly, you can plan improve the efficiency of the total compressed air system as such. This is what it is happening in the dryer. See, 2 3 stages of drying the air, compressed air. One is at the compressor end by the post air cooler. then by the air receiver, then by the refrigerator dryer. The refrigerator dryer, the intermediate losses where we have observed almost some hundreds of units in the industry, we have seen almost 1 to 1.5 bar is getting dropped across the refrigerator dryer because it is not maintained properly, and the Freon system R22, R12 or R402 that needs to be maintained to have a healthy the air intake, that is the inlet temperature of the dryer is around 5 degrees above the ambient, means the outlet temperature needs to be around 5 to 10 degrees below the ambient. This shows the healthiness of the dryer. See, these are all the intermediate power transmission losses. It's a energy influencing parameters, not the direct power, but if the parameters are not healthy, then it definitely the pressure drop is more, means, say every 1 bar, B has suggested every 1 bar almost 6 to 8% of power loss is happening. The power becomes high asset. To the motors in general, the load side optimization is a low hanging fruit. I'm just trying to see the compressors, motors, boilers, blowers and fans, and all the other utilities. Load side optimization, you try to achieve it. Then comes the motor which is running at 50% loading and below 50%. That is why the IE3 motor, IE4 motor and IE5 motors, where the efficiency curve is a broader and a better curve than the IE2 or IE1 motors. Let us say IE1 motors. See, a IE3 motor with VFD, what is the result you see for yourself? Then a IE5 motor, what is the result you see for yourself? For the given production, for the given motor loading of your industry, which is giving a better output, definitely this is saving for us, because almost 95% or say 99% the motor cost to power cost is very much more for the life cycle costing. So investing in motor is definitely a welcome trend now. It needs to be accelerated. The national NMRP is the National Motor Replacement Program has come, but still it's not happening as it has to happen from IE2 to IE3 or IE3 with VFD. VFD, especially for blowers or the centrifugal machines, it is becoming mandatory now. You see this, and with respect to IE5, where do you stand? And definitely you have to jump into the wagon of higher efficiency motors. This way I was suggesting, whenever the machine or the production is lean or rich, full loaded or less loaded, you have the auxiliaries with the KWH and run-over motor on the combo meter on all the auxiliaries of your machines, subject to your usage and convenience. This will definitely show if the loading is less than 50% or 40%, there is a loss, heavy loss. If the loading is around 60 to 80% only, the motor, the energy efficiency for the given motor, right from IE2 to IE3 to IE5, it is all excellent as such. So the shaft RPM of the motor is more important to know the slippage for the given loading as such. Then comes the lubrication. Instead of going for a multi-purpose grease and all, the specialty grease like polyurethane thickened that is lithium complex grease, that itself is doing a better job. Like some of the motor OEMs, they give for 2 to 3 years guarantee, that is refilling time as such. The temperature, the grease is supposed to dissipate the temperature from the bearings to the skin, and in the ordinary multi-purpose grease, it will not do the job for us as such. Ventilation also, in some of the motors, even if we can increase the ventilation fan, depending on the harsh environment, the size also can be increased to see that the motor end-to-end driven and non-driven temperature is almost near than 10 to 15 degrees temperature difference is there as such. Thermography, it definitely plays a big role. It's a daily usable tool in the industry to have both the input, output, as well as in the intermediate stage power monitoring. Hotspot is a symptom of energy loss. Wherever the energy is getting stuck in a given stage or an intermediate stage, that will show the hotspot. This is where you have to take the immediate action. It is a daily usable tool now. The thermal imager has become very affordable now. It has come to less than a lakh. And micro level monitoring of energy influencing parameters at the input of the system, intermediate system, at the delivery of the system. And macro level analysis has to be done immediately for each and every system to go for the reliability based condition monitored maintenance as such. This is an area where belt driven motors, maybe it's for a blower or it's for a machine, some of the belts and pulleys are rated only for 40,000 hours, but we are using it for more than 10 years and all these pulleys. It has faced almost 10 numbers of bells, 10 cycles of bells, and the pulleys have worn out. Means definitely the temperature of the pulleys and bells, everything, it goes up. This is an area, visible loss area, where we can look into it as such. Coming to the blowers and fans, it's a variable torque load, as I was telling you, and you have to follow the torque and the incoming power, the power given to the motor as well as the torque. If it is following one by one equally near, then you can have achieve the savings. But thanks to the VFD, that will only facilitate, especially for the variable torque blowers and fans as such. Here on this VFD, we have done a case study. In fact, hundreds of case studies have been done on this blower with belt and VFD conversion. Belt, instead of V-belt, it has been changed to cocked belt and resized pulley. And VFD has been made to facilitate to, this will try to match the demanded torque and the delivery torque from the motor and the demanded torque from the blower. So you can see at 50% of the speed of the given blower, the torque is around 25% only. Whereas at 100%, both are same, but at 50%, this is torque is at 25% only. This is the area we are trying to make use of it and try to achieve the energy savings in many of the blowers. It is a very low cost investment. Say it's costing around 10,000 or 20,000 for an existing VFD operated blower. This gives a savings of almost around 15 to 20%. I can also show you the case study here. This is a case study done in Danfoss. They are basically a reputed VFD OEM, and at the Chennai plant, it has been done. You can see on a 18.5 kilowatt, it's a 25 HP machine blower, VFD AHE blower only. For the same given blower RPM of 860 RPM at 50 Hertz, at 33 Hertz, at 30 Hertz. The energy savings is only at 50 Hertz because of the change of belts and the pulleys from V-belt to cocked belts, from a number of 3 belts to 2 belts, and this V belts to cocked belts. This gave a savings of almost 11% at 50 Hertz. But all the industries are really good. They are trying to have the VFD for many of their AHUs. They are trying to operate the AHU by just putting the daytime on Hertz and nighttime on Hertz, and summertime, wintertime, they are operating at different Hertz to have the energy savings as well as maintain the indoor premises air quality also. On the same VFD, now being the winter time, this industry has done from 33 Hertz they were running, and from 33 Hertz they have gone to 30 Hertz, and they are maintaining the same blower RPM around 550 RPM for the given blower, but they are able to achieve almost 22% energy savings. This is a very low cost, instantly implementable, and with no, say, EC fan is there, it is costing more, and the total system change is happening. But whereas on the existing system, on the same motor and the same blower, only the change of VFD settings and the change of the power transmission components, especially from cocked belts, from this V belts to cocked belts, which carries more power carrying capacity. And the resized new pulleys. The pulleys also needs to be changed every 40,000 hours. This is mandatory. The OEM has to educate the end user as it. So this is an area which we are even trying to take it to the Bureau of Energy Efficiency, and it is a universal phenomenon. I'm not trying to talk about the affinity loss of the blowers here. I am trying to talk about the torque that is delivered by the motor, torque that is demanded by the blower. There is a gap. This exercise is addressing to that, and this will definitely address thousands of motors are there in each and every metro cities on the building segments, and thousands of blowers, waste collection. This is not only on the AHU system. It can be it is done on ID fans of the boilers. It is done on waste collection systems on the textile segment. It has been done in proven case studies have been done. More than around 1,000 case studies have been done. But still, this needs to be approved. It needs to be recognized and approved by the policy making authorities so that the industry can make use of it. It's a visible loss that is happening in the industry, especially on the VFD operated, belt operated blower. This can be definitely, it's a instant implementable energy savings. Any VFD for that case, if it is operated at 50% only, this is an excellent way. It's a excellent variable speed drive candidate, especially for a 50% or partly loaded blower only. The VFD is doing an excellent job. If the blower is already running at full speed, BFD does not do any job. BFD is a waste there. It is an add-on. It's an added expenditure of a BFD of an already fully loaded blower. That is a waste there. So see to it that the blower is loaded, part loaded, and there the VFD will definitely facilitate the energy savings, facilitate the torque gap, and it will give excellent savings of 20 to 25% on the existing motor itself. You are aware that the blower efficiency is around 50% only. Since this is the new rated blower, and over years it drops to almost 35 to 40% only. So this can be definitely be pulled down. The blower system efficiency can be improved from 40% to 60% by this instantly implementable exercises. You can say a 5 HP motor, especially on a AHV unit, almost 40% goes towards the loss. That is the hot spots, heat loss. One at the motor end, one at the drives, one at the fans, and the output is, see, on a 3.7 kilowatt motor, 2.2 kilowatt only is delivered at the output, whereas 1.5 kilowatt is delivered as hot only, heat output only, as on the skin the heat or on the drive heat. Everywhere it is a loss. Around 40% is the loss. This can be definitely be reduced. Intermediate power transmission losses can be reduced. It is not only on the centrifugal blowers, it is on the axial flow blowers also, especially on the textile mills or any industries where they are using the axial flow fans. The industry always assumes it is a 1200 mm fan, a humidification plant, axial flow fan. On 1200, 500 mm is the hub dia, and around 350 is the blade length. The tip, that is the rear, you can see the tip clearance. This is where almost 50 mm was the tip clearance in this. Almost 15 to 20% was the flow loss that is noticed in the industry. They immediately took the step after our audit. They found they are able to restore the flow rate of the blower by almost 15% here. Any the 1% of the blow length, see, normally it is supposed to be around 4 mm only, but here it was 50 mm. I am trying to give the specifics of the minute details of the point of tip clearance details. See, a blade length is 350 mm means almost 1% means only 3.5 mm. Around 4 mm is allowable, but you are keeping around 50 mm. See, why this is happening is the motor is fixed on the blower, and they have it gets slightly tilted, or the gap between the blower tip and the outer ring. If the gap is more, then it is a loss of 10 to 15%. This is an area to be looked in immediately. And another thing is, if you see the blades of all the axial flow fans, aerodynamic profile has become mandatory. It needs to be implemented. We are all using the gravity die-casted fans, but this gravity die-casted fans, it's a past year, this one. But the recent years, we go for an aerodynamic profile that definitely gives the fan efficiency. It improves by almost 15 to 20% as it. So from 40% of an axial flow fan, you can almost bring it to 70% efficiency of the axial flow fan system. It is not only by the fan and the tip clearance, but it is also by the inlet cone. We call it as a lotus inlet, and lotus like this one inlet, and the delivery cone. This needs to be there in each and every axial flow fan of the given system. That needs to be there, and not only that, and the tail nose flaring and the tail fairing, especially on the motor covering and on the delivery end, if this needs to be covered. Ultimately, we want the airflow at the section of any axial flow fan to be smooth, streamlined, and laminar. If the laminar flow is disturbed and turbulence happens, automatically the energy loss happens. It comes to almost 10 to 15% from laminar flow to turbulence flow. This is not only on 20 HP blowers or 50 HP blowers. This is happening in higher end blowers also. Why we are using the velocity recovery rings for all the HVAC cooling tower velocity recovery ring that tries to restore the turbulence of the flow that is outside the condenser fan, and that needs to be there not only for the heavy duty 400 ton or 60 ton cooling tower, but even for a 1.5 ton split AC also on the high side of your high side outer unit, you can have your velocity recovery ring by few inches. If it is fixed on the fan, it will definitely tell upon your fan efficiency. It improves your condensing this one. The heat transfer efficiency is improved on the outdoor fans also. So the four fundamental ways of energy saving is, one is monitoring the energy and target the energy consumption. Accurate monitoring not only on the process, on the auxiliaries, on the utilities and the exhaust areas. That is what I am trying to add here. The exhaust areas, what we are doing in the boiler for the indirect efficiency, we will let us try to have the same horizontally deployed for all the electrical utilities. Try to monitor the what all the exhausted areas to the atmosphere. If this is monitored, this will give you a symptom of what is the energy loss, how this can be reduced upon as such. Second step is in trimming or optimizing the input energy content for the given process. See, some of the waste collection systems, the OEM said or the processman said we have to operate at 1000 pascals. But now the OEMs, now many of the textile industry segment, they are operating at 500 pascals and they are jolly well doing an excellent job. So the OEM always talks about the safety of their machine or safety of the process, but the energy saving is also a priority. Let us try to optimize the energy parameters, energy influencing parameters. Optimize the Pascal in all your blowers. You will see an immediate 3 to 4 months payback, immediate result, and your energy bills will reduce right from day one as such. Third step, this is a zero cost or low cost implement only. Third step is trapping the unused energy. Wherever the process demands it, the rest is going as unused energy. Where that can be trapped. See, when I worked some 15 years back on the user group Germany, they said what all the processed water that is delivered by the textile processing units, it was more than 40 degrees centigrade means they said this is the area to be tapped and let us try to recover the heat that is there above 40 degrees centigrade, the water which is having 40 degrees centigrade. Now we are just putting out the water with more than 60 degrees and 70 degrees in the engineering segment or in the processing segment. That needs to be trapped and it is to be used. It's a low grade heat, but definitely it is worth the usage asset. So fourth is the recycling of all the and usage of energy over and again. The recycling is definitely becoming a important area or a domain for the achieving the circular economy. So let us try to keep in mind all the daily running energy efficiency of all our utility equipments like compressor, pumps and blowers and boilers, or even the gensets. Gensets also, everything it's around 30 to 60% only, and this needs to be improved upon by 10 to 20% right now as such. Thanks for giving this opportunity. I am trying to cover some of the areas where the energy scope is there, not only at the input side trimming area, in the intermediate components, intermediate power transmission components. This is the area we have to look at. And you know pretty well that we have not monitored because the OEM has not told us. Let us discuss with our OEM. Let us have the breakup. Let us say a machine is there or a productivity equipment is there. What is the breakup of the machine at the input? What is at the pre-input stage, at the incoming stage, at the processing stage, at the delivery stage, and what is at the delivery stage? What are all the enthalpy figures, that is the embedded energy in each and every system at the raw material input, at the incoming input, at the intermediate area? Each and every enthalpy is seen automatically. This can be retrieved. This can be restored. I am not trying to say let us not try to overtake the energy efficiency given by the nameplate by the OEM, but let us try to restore the efficiency. Each and every motor OEM says around 90% is the efficiency, but all our motors are part loaded only. It's around 60% or 70% only. How this can be improved upon? Everywhere the nameplate efficiency is different, the part loaded efficiency is different. The part loaded efficiency is where we are mattering more. We are trying to address that more and try to optimize the input and the intermediate stage to achieve the gap between the nameplate efficiency and the part loaded efficiency. Thanks for giving this opportunity. Thank you. I will be more happy to receive your questions as such.
Yeah, thank you, sir. That was a very nice presentation, and your presentation definitely speaks about your experience in the field, and quite practical examples were given during the presentations. And I hope everyone will be benefit from this session. Now I request everyone to put down your questions in the chat box so that Mr. Ashok can take it up. In the meanwhile, we have one question, and that is from Mr. Brijesh. So he's saying, will it be not possible to provide these details to machinery manufacturers, and it's mandatory to follow to efficiency at roots?
You are very much true, Mr. Brajesh. It needs to be taken over. But now it is happening the reverse engineering, like what the user needs to take up. The energy auditors, we are like a bridge between the user and the OEMs. And definitely the user needs to take, see, you have spent lakhs of rupees to buy this equipment, but the life cycle costing of equipment is more important to us. So definitely you have to take it to the equipment to OEM and leave alone the safety of the equipment. That is more important. Safety is the undercover, but that is upon which energy efficiency and optimization needs to be achieved. You discuss with the OEM, you motivate your OEM to get more details how the energy saving can be done on your 10-year-old machine, on your 5-year-old machine. This needs to be done. It's a nice question. It is a proactive discussion between the user and the OEM, and the energy professionals are in between. Definitely, we can definitely activate as it.
Yeah, thank you, sir. I hope, Mr. Brijesh, that answers your question. And can we have further questions? Are there any questions for Mr. Ashok? Yeah, and like if you want to speak, so you can raise your hand so that I can unmute the mic for you. So Mr. Balkrishna Chodankar, he is asking, how effective is the pinch technique in conservation?
Definitely, it is very much effective. Let us try to first get this basic inputs on the condition monitoring. Let us go ahead on this, and definitely that is a technique by itself, and it's a proven only, and definitely we can take it up as it. But normally what we have seen is Bureau of Energy Efficiency has suggested each and every energy consuming industry monitoring not only at the input. See, as I said before, compressed air monitoring, every industry is doing it. Say 1,000 industries are monitoring the input at the compressor, but they have not seen the delivery trend of the compressor, delivery flow of the compressor. Not only for the compressor, it can be seen for the blower, it can be seen for the pump. But these are all very, blower or the pump, it is very costly. But for the compressor, it has become affordable. It has come less than a lakh, and it is a mandatory now. This ENMS or this IoT is definitely going to play a big role by monitoring the RPM of each and every machine. Say motor is there, blower is there, motor is there, pump is there, or any of the machines. Motor and machine, what is the loss, and this is monitored, and the slippage happens when it is fully loaded, and the slippage does not happen when it is partly loaded. See, this is the area we have to find it out, pinpoint it, and then get it done as it. Thank you.
Yeah, Mr. Bhaskaran has raised his hand, and like he is allowed to talk. So Mr. Bhaskaran, you may share your query. Yeah, Mr. Bhaskaran. Mr. Bhaskaran, can you unmute your mic? Anyways, there's another question from Mr. Avinash Shinde. And okay. Yeah.
Yes, sir. Yes, sir.
Mr. Sethuraman, good afternoon. It's a wonderful presentation. Two things you can add in your thing. One, heat recovery. Then there is one more thing in compressor, optimization of oil flow. Compressor has been designed for certain pressure and at certain ambient conditions. But most of the clients, they use at lower pressure, and ambient is also low, load is also low. So we can definitely optimize the oil flow by using some small restrictors. after monitoring. Actually, I have done in some industries. I could get around 3 to 5% savings in compressor permanently. Some compressors. And the heat recovery also I done in many industries. In fact, we have stopped some boilers also using heat from compressor.
Excellent, sir. Excellent.
Yeah.
Great.
Your input, I appreciate your input. Definitely, the oil, that is the heat of compression, is totally borne by the oil only. The oil flow matters more. And definitely, one is the HOC and the oil flow, and the other one is low grade heat recovery. In fact, I wanted to cover more on these aspects, but lack of time, and within this 1 hour, I have to cover many topics. I was covering it, but what all the points you said is well taken, and definitely the industry or the industry users will definitely make use of it and will proceed on these lines, because these are all the areas, intermediate areas, the oil circulation, oil lubrication, this area, the compressed air users have not thought about it much, because the OEM has to educate them. Once they educate them, definitely they can look into the oil flow, oil temperature and pressure. Then is the low grade heat recovery, what all the industries we have seen, everywhere the heat is just vented out only from the compressor, almost a low grade heat, but it's almost 70 to 80 degrees heat is coming out, hot air is coming out. That needs to be used. I thank you for your input, and it's well taken. Thank you, sir.
Yeah, thank you, sir. Thank you.
Thank you, Mr. Bhaskaran. We would also like to hear about your case study sometimes. Do write to us if you are interested to present it.
Yeah, definitely, I can share my case studies. In fact,
Sure.
I have
Yeah.
been in this industry for quite some time. I've done a lot of things
Great.
in compressors. I can share
Great.
that.
Definitely, I'll get in touch with you.
Yeah.
So now let's move on to the next question. And next question is from Mr. Avinash Shinde, and he's asking whether IE4 VFD is required for IE4 motors.
IE5 motors are coming with built-in VFD. This IE3, IE4 motors, you have to use your VFD. And what all the motor replacement, what we are talking about, the industry is talking about, instead of straight away replacement, you do the apple to apple comparison. Now that's what it's normally said. You have your own motor, say IE2 motor or IE3 motor, you put the VFD, you see the savings. See, the energy conservation or the replacement can happen only when already the existing system is efficient. How to improve upon it further, that is more important now. So IE5 definitely scores a better score than the IE4 and IE3, but let us see with IE3 and IE4 with VFD, what is the condition, what is your case study, what is your parameters measured, and then on the replacement there with IE5, that is with inbuilt VFD, definitely you see the savings, and accordingly you can plan. The payback period that decides the, because the rate is investment cost is more on this IE5 and IE4 as such.
Yeah. So here I would also like to add, like for higher rating motors, IE5 motors are at present not available, and definitely IE4 motors can be used, and you can have an VFD along with it, and definitely savings are great. Like we have done many installations for IE4 as well as IE5 motors. So wherever it is required to go for IE4 motors, we go for IE4 motors. And if IE5 motors is available, then definitely we will be choosing the IE5 motors only. So IE4 or IE5, but in both cases, the results are very good.
Excellent, excellent. In fact, many of the industries here we have done this case study on this IE4, IE5. We found one critical, and that is one subtle. This one input is wherever the loading is around 40%. IE4, IE5 does an excellent energy savings than this IE2 or this IE1 motors. So loading, the efficiency curve for the IE4, IE5 becomes broader and broader. Say it covers from say almost 25%, 30% to almost 90%, 90%. That is a big area, because everything it depends upon the production. The given production wants only the motor at 40% loading, means that IE5 stands a best chance as such, IE4 or IE4. Thank you, ma'am. Thank you.
Good. Now, Mr. C. Sharma, you may please put up your question. You are allowed to talk. Yeah, Mr. Sharma, you may unmute yourself and talk.
Yeah, am I audible now?
Yeah, you are
Yes.
audible.
Well, thanks, sir, for the nice presentation, and it was really helpful.
Thank you, sir.
I would like to ask, rather clear my doubt about the V belts and flat belts. So, around 35 years back, we read that V belts are much efficient than flat belts because the slips occurred in the V belt drive as well as in the flat belt drive. In case of V belts, it is less slip as compared to the flat belts. So the V belts were chosen for better torque transmission. And recently, I have heard, I read somewhere that people are replacing V belts by flat belts for achieving the energy efficiency. I was surprised to read this, and the doubt came into my mind since you were talking about this. So I would like to clear my doubt from you. Can you please enlighten us?
I sincerely appreciate your minute questions. The flat belts are gone by, that is, industry went for the flat belt because they did not want to have a slippage between the motor and the machine. That is why they went for the flat belts. But the flat belts, the self-consumption of the flat belts and pulleys, that is more now, because after seeing all the intermediate stage measurement, power-wise measurement on the power transmissions, we found in between this one, from V belt, if the industry changes over to the cocked belt, especially for all the blowers, I'm not talking about any industry, it is a universal suggestion that the blowers are all variable torque loads. This can accept the cocked belts, which is almost the power carrying capacity for a cocked belt. It's again a V belt with a tooth, inner tooth, that's it. But that is having almost 30% power carrying capacity more, and it can accept a lesser pulley size also. The heat is that is coming out, heat that is coming out emanating from the cocked belt is less compared to the V belt. So I am suggesting in between, from a V belt to flat belt, instead of going for that, let us try to go for a cocked belt where this can give an excellent, almost it's the double. Let us say the V belt used for 6 months means this will come for 1 year as such. The life of the belts is more, and the pulley and belts are maintained correctly, and the power saving, the self-consumption of the cocked belts, almost 50% the weight drops between the V belts and the flat belts. Instead of 3 belts or 4 belts in a 4-groove pulley, just a 2-groove pulley with 2 belts, almost the weight also reduces, and the self-power consumption also reduces on a cocked belt compared to a V belt or a flat belt. That is the area which we have tried to make use of it, and the VFD as a facilitator to bridge the gap between the torque demanded and the delivered torque and the demanded torque. Both the VFD and this cocked belts is an excellent permanent solution for all the blowers, not only on the residential building segments, for all the industries, high capacity blowers also, or for the less than 10 HP blowers also. Thank you, sir. Thank you.
Yeah, thank you, Mr. Yeah.
Thank
Yes,
you. And one more question to you, ma'am. Whenever I logged in, my name appears at C. Sharma. I'm not C. Sharma. I'm MD Sharma. So
Okay.
can you please
Okay,
change-
definitely. I'll look into it and get it corrected.
Okay, thank you.
You may
Thank you,
just ping me on my WhatsApp number and give me the correct details, so your email address, etc. I'll type my email address over here, and like if anyone has any queries regarding these sessions, you may get in touch with me. I'm just putting my email address in the chat box so that everyone can note it down.
Okay, thank you.
Thank you.
Yeah, and now again, there's a question from Mr. Chodhankar, and his question is, what is the optimum velocity of water in the pump discharge lines from energy conservation point of view? So we
Yes.
have many other questions also, but I think this is the last question that we are taking in, and all the questions will definitely be conveyed to Mr. Sethuraman and your email addresses as well, so that he can get in touch with you.
The optimum velocity, this again depends upon the what is your source the point velocity and what is the delivery point, this one. See, what is the heat transfer, what is it the application like? The application decides the velocity in meter per second for the given water, and this depends upon the pressure and the velocity based on the application. Heat transfer applications, especially in the indirect heating, especially on the thermal side, we find lesser the velocity, this is applied on the compressed air. It is similar to the water also, but water is being a liquid. The velocity depends upon the heat transfer application, depends upon the OEM's recommendations. This is not a universal values. If you ask for a compressed air, we can say it is a universally it is said say 10 meters per second, 20 meters per second, but that is also it is getting changed because in between turbulence can be definitely be addressed upon by intermediate air receivers as and when required. One at the source receiver, air receiver at the compressor house, so delivery air receiver, tail end receiver at the load end, and the intermediate receivers to neutralize or make the air velocity streamlined. When the air velocity becomes turbulent, it is a problem. And what are the velocity? It depends on your OEM and depends on your applications. Thank you.
Sir, can I just intervene? Meaning, can I ask you further question? Yeah, as regards to this Balakrishna here, I had asked that last question. Now, my question point of asking was when you transfer fluid from one point to the another, the frictional head lost, it takes some power. Now, if you increase the pipe diameter, the capex increases, capital expenditure is higher. Now, if life cycle analysis, if you do, what should be the optimum diameter of the pipeline? If you go for higher initial cost, then the operation cost will reduce because frictional losses will be less. Now, I was asking from that point of view, normally we used to keep around 3 meters per second, 3 to 3.5 meters per second in discharge lines. But if the cost of delivering the water is higher, it is better to go for higher diameter, that means lesser velocity. So from that point of view, my question was, not from the heat transfer point of view.
Yeah, I agree. In fact, for any of the water application, when the industry changed over from MSERW pipes or GI pipes to this PVC pipes, from a 4-inch line to from a 3-inch line to 4-inch line, the industry changed over. They found the friction coefficient on this one, it dropped by 20%. So the friction coefficient of the water with respect to the application, this matters more here. But energy savings is there. Definitely, when you are making the conductors more and the rotators small, it is a universal thumb rule. But the conductors or the pipelines need to be bigger in size, not only for the water and for the air. And definitely, this definitely improves the end-to-end velocity, and it is streamlined, and it is kept optimum or laminar asset. Thank you. Thanks for your valuable query.
Thank you, sir. And I think most of the questions have been answered. Yeah, Professor Gande wants to share a couple of things. So definitely I'll be giving him this opportunity. Let me check if I can. Yeah, Mr. Gandhi, you may put up your question now. And Mr. Luhadia, for some reasons, I am not able to put you on. I mean, there is some problem with that. So you may put up your question in the text box, please.
Can you hear me, madam?
Yes, we can hear you, Mr. Gandhi.
Congratulations, Mr. Ashok Sethuraman.
Thank you, sir.
You have dealt with the subject very precisely, finishing off for the presentation in 40 minutes or so on such a wild, coverage is very, very extremely difficult, but you have done it very, like an expert. want to
Pranams to you, Professor sir.
Yeah.
Thank you.
Very wonderful presentation.
Thank you,
I
sir.
just wanted to, of course, we can see that you have. I can see 5 books in your name. I can see them,
Thank you, sir.
and also your 1,000 audits and so many papers speak of your experience. Wonderful.
Thank you, sir.
Presentation.
Humble
Certainly,
pranams to you, sir.
yeah. Certainly, I think I'm sure that those who are attending this webinar must be benefited by your experience, and of course, I'm sure that you will be available to them again. My couple of things I just wanted to add you. You have mentioned many things, but I would just like to add a couple of things. The leakage testing is one of the major, especially in compressed air and steam distribution systems. Leakage testing also has to be done very periodically, because unless you measure the leakage and then take the step, you don't know how much saving going to be there. See, and also measurement of the pressure drop, across compressed air and this system will be also very useful. One more suggestion that you may like to add in this thing is the equipment, requirements of pressure, especially the compressed air pressure and also the steam pressure, very important. And the study of the equipment about the requirement of the pressure is also very important. I think these are a couple of areas, but I think both all these 4 or 5 systems you have got very nicely. Congratulations to you. We hope to hear you again, and of course I will note your email address and I will contact you, because we also have a similar lecture series. I think Bhavana Chitkavar knows it, and maybe if she permits me, I can approach you for a lecture in our series. Okay, our series is 2 years old, but it is similar series.
Thank you, Professor.
I'll be
Thank you,
sharing
Professor.
your contact. I'll be sharing his contact details to you, Mr. Gandhi.
Thank
so
you,
that-
thank you. Wonderful.
Thank you, sir. Thank you, sir. Your points are well taken, sir. In fact, you have correctly said the load point of usage monitoring is more important. That is what
Yes.
we are trying to highlight this. And the point of usage, especially on the tail end equipments, not only on the steam side, especially on the compressor side, the
Yeah.
end-to-end pressure drop and some of the equipments, they need only 4 bar or 5 bar. Still, we are
Yeah,
operating at
that's
7
true.
bar. This
Yeah.
is an area I really appreciate your input on this. Thank you very much, sir. Thank you,
Yeah,
sir.
thank you. Thank you.
Thank you, sir. And it was a great session. I hope everyone is benefited out of it. And stay tuned. And like always, we will be sharing the recording of this presentation on our YouTube channel, AEEWI Western India. And you can take the benefit of this by subscribing to the channel and keep attending our sessions. It is very heartening to see that many of you are regular for these sessions. So keep attending these sessions. Thank you very much. Thanks,
Thank you so
everyone.
much. Thank you so much. Thank you.
Thank you, sir, once again for giving your valuable insight for this session.
Thank you, ma'am. Thank you.